Okay, let's try problem 1.54. Satellite data, ignore that typo, taken several times per hour on a particular albatross, show travel of 1,200 kilometers over a time of 1.4 days. Given these data, what was the bird's average speed in miles per hour? Okay, so let's just do that first. So if you remember, velocity is equal to distance over time. Distance over time. So we're given the distance of 1,200 kilometers. 1,200 kilometers in 1.4 days. Okay, so now we're not asked for it in kilometers per days, we're asked for it in miles per hour. So again, we have to convert our units. So we know that in 1 day, there are 24 hours. Just multiplying by units of 1 here to get in the right units, so days cancel out. And then we also know that there are 0.621 miles in 1 kilometer. So now the kilometers cancel out, and we're left with miles over hours. And so when you do this all out, you're left with 22 miles per hour. Okay, so that's the solution to part A. So let me label this over here for you. You can't see that. A. Okay, now let's grab a different color for part B. So part B. This one's more of like a thought experiment, really. So data on the bird's position recorded only intermittently. Explain how this means that the bird's actual average speed was higher than what you calculated in part A. So when they collect this position, it's not collected continuously. So it's not like on the back of the bird's back and it's got a little GPS map showing where it's going. It's collected like every, let's just say for this problem, every hour it's collected. So the position is nailed here and then it's nailed over here. So this is over the span of 1 hour. So we'll call it 0 and this is 1 hour. So if we just know the bird's position here and the bird's position here, we don't really know what's going on in between. For instance, if the bird took this path, some crazy path like that, and then we knew he ended up here, there's no way for us to know how it happened in the middle. We only know what happened at the two endpoints. And for that reason, for the average speed, it just makes it appear as if it's simply just traveling in a straight line from this dot over to this dot. But it's not, it's actually making this path. And so we know that its average speed is 22 miles per hour, but we don't know what happened in between. And so he's covering way more distance here in the same amount of time than if he just took a straight path from this point to this point. So for that reason, the speed has to be higher than what we calculated here. So for instance, if it was double the length, he would have to travel double the speed. Just to give you an idea about that. Okay, so let's problem 1.54.